One of the biggest challenges in AI, one of the things that holds it back, is memory. It's a huge hurdle. But what if an AI could actually remember things, like we do? Well, today we're going to dive into two incredible breakthroughs from Google Research called Titans and MIRAS that are doing just that, giving AI a powerful, brand new way to remember. Okay, let's start with a question that seems simple but is actually really deep. You can feed a massive 500-page document to one of the most powerful AIs in the world right now, but by the time it gets to the end, there's a good chance it's completely forgotten what was on page one. It's a surprisingly common problem, and it's stumped researchers for years. And it all comes down to this fundamental trade-off and how these models are built. So on one side, you have transformers. Now, these guys are incredibly accurate because they can literally look back at every single word they've ever seen. But here's the catch. That accuracy comes at a huge cost. They get painfully slow and super expensive to run as the text gets longer. Then on the other side, you've got recurrent neural networks, or RNNs. They're lightning fast, very efficient, but they achieve that speed by kind of squishing information into a fixed-sized memory. And that means they often forget crucial details from way back at the beginning. So this classic trade-off, this dilemma, is what the experts call the long context problem. It's the real reason why AI has such a hard time with things like summarizing an entire book or analyzing a full string of DNA. You either get accuracy or you get speed. You couldn't really have both. Well, until now. The researchers behind this new work, they looked for inspiration from, well, the most powerful computer we know, the human brain. Just think about your own memory for a second. You don't remember every single moment of your day, right? Of course not. You remember the stuff that stood out, the surprising conversation, the unexpected event, the important detail. So what if an AI could do the exact same thing?
And that, right there, is the brilliant idea behind Titans. It's a completely new AI architecture, and it was designed from the ground up to solve this long context problem by giving AI a much more human-like long-term memory.
Okay, so how does it actually know what's important enough to remember? It uses this really clever idea called a surprise metric. Think about it like this. If the model sees something it totally expects, like the word cat at the end of a very famous phrase, the surprise level is low. It doesn't waste energy trying to memorize that. But if it finds something totally out of place, like a banana peel mentioned in a serious financial report, the surprise level is super high. And that's a huge signal to the model. Hey, this is weird. This is important. Store this in long-term memory.
But it gets even smarter. Titans refines this whole process with two extra mechanisms. First up, you've got something called momentum. This helps it capture not just one single surprising word, but all the important context around it. And second, there's forgetting. Because just like us, the AI needs to be able to clear out old, useless information to make room for new, more important memories. It's just an incredibly efficient system.
So you've got to think of it like this. Titans is the specific, powerful tool that makes this all happen. But the researchers didn't stop there. They went a step further and created something called MIRAS. And MIRAS isn't just one tool, it's the entire blueprint for building a whole new generation of memory-efficient AI. All right, let's unpack this blueprint, MIRAS. What it does is give us a whole new way of looking at all kinds of models that process information in a sequence. It basically argues that, whether you're talking about a transformer or an RNN, deep down, they're all just different ways of building what's called an associative memory, a system that just learns how to connect related pieces of information. And the name itself, it tells you just how significant this is. MIRAS actually means legacy. And that's because this framework is really intended to be a foundational contribution, something that future research is going to be building on for years and years to come. Okay, so take a look at this. This slide really gets to the heart of the framework. You can see here that MIRAS breaks down this really complex problem of AI memory into 4 fundamental design choices. This gives researchers a super clear, structured way to think about and build new models. We're going to walk through each one. All right, so it all boils down to these 4 pillars. First, you have the memory architecture. Basically, what kind of container holds the memories? Is it a simple list, a matrix, or a complex network like in Titans? Second, the attentional bias. What does the model care about? What does it prioritize? Third is the retention gate. This is the forgetting mechanism. How does it decide what to keep and what to throw away? And finally, the memory algorithm. How does it actually update its memory with new info? The cool thing is, every sequence model, old or new, can be described using these 4 choices. Okay, so now let's put it all together. Titans is the specific tool, and MIRAS is the blueprint it was built from. So for its memory, Titans uses a deep neural network. For paying attention, it uses that surprise metric, and to decide what to forget, it uses that adaptive decay. It's this synergy, the tool and the blueprint working together, that is so revolutionary.
Look, this all sounds absolutely fantastic on paper, right? A model that's super fast and has a nearly perfect memory. But the real question, the one you're probably asking, is does this new approach actually work out in the real world? How does it stack up against the current champions of AI? Oh, yeah. And the results are, well, they're pretty staggering. Just look at this graph. It shows how well different models do at finding a tiny piece of information, a needle in a haystack, inside a gigantic document. You can see that even massive models like GPT-4 start to really struggle as the document gets longer. But look at Titans. It's a much, much smaller model, yet it maintains this incredible accuracy, even when it's dealing with over 1 million words. It's not just a little better, it's playing in a completely different league.
And get this, it's not just about reading documents. The power of this architecture goes way beyond language. It's already proven to be effective in other incredibly complex areas, like modeling entire strands of DNA or forecasting complex financial data. The principles are truly universal.
So, let's take a step back. What does all of this really mean? Well, the introduction of Titans and the MIRAS framework isn't just some small, incremental improvement. It really represents a fundamental shift in how we design and build AI, opening the door to solving problems that, honestly, were pretty much impossible before because of these memory limits.
As the researchers themselves put it in their paper, this work basically changes the entire playing field. What they've done is provide both a practical tool and a theoretical framework that gives us the best of both worlds, the efficiency of those old-school RNNs with the raw power we need for the modern era of massive context AI. And that leaves us with this one kind of huge thought. For years, we've been building these incredibly powerful AIs, but with a flawed, fleeting memory. Now that we have a blueprint for giving them a near-perfect one, what's next? What new discoveries will an AI uncover? What new art will it create? What problems will it solve for us when it truly never forgets?